Alright, so in our last video we ended up in this form with our linear system where we've simplified our matrix to have zeros in the first and second column underneath an entry, right? And in our last column, in our third column, we just have one entry. And this is what this kind of represents in our linear system view of this with our variables included. And we've gone now from having 3 variables originally in our third equation to now just having it in terms of 1, right? And what we found is that x3 is equal to 3, all right? Now, we're not quite done yet though, because we can actually simplify this a little further. And what we'll see is that we can actually get each one of these equations to be represented by one variable. And it's going to be through the same method as we did last time, except this time we're going to go up. Alright, so let's focus in here on our matrix. And what we want to do now is get zeros above this one entry. So here and here, and we want to get a 0 above this middle entry. So we want to get rid of this -2. So let's go ahead and do that. And you're going to be using the same methods as before. So what we're going to get now, what we're going to do here, is we're going to say 4 times row 3 plus row 2. And we get 4 times 0, 0, 1, and 3. Alright. And we're going to add that to 0, 1, -4, and 4. Well, 4 times 0, again, is just 0. So let's go ahead and say that. And then 0 plus 0 is 0. 4 times 0 again is just 0. Plus 1 is 1. 4 times 1 is 4. Plus -4 is 0, which is what we wanted. Again, this was our objective, right? We want to make this entry right here a 0. And then 4 times 3 is 12. Plus 4 is 16. Alright. And again, we go ahead and rewrite our matrix. This is one that we're multiplying by. It does not change. We didn't do anything with row 1. It does not change. Now row 2 is the one that changes. So 0, 1, 0. Again, that was our objective. And then 16. Alright, so that's looking good. Now, let's see what we can do to get rid of this top entry right there. Well, in order to get rid of the top entry, what we're going to do, because again we want to cancel it out, is say negative times row 3 plus row 1. We're saying negative, and I'll go ahead and even put this there, -1 times row 3. And I'll do this even. -1 times row 3 plus row 1. What do we get? Well, we're going to have, we're saying 4 times that. So let me go ahead and write out the 0, our 1, and our 3. And we're going to multiply that by -1. Alright. And we're going to add that to row 1. So we have 1, -2, 1, and 0. And what do we get? Well, -1 times 0 is 0. So 0 plus 1 is 1. -1 times 0 is 0. Plus -2 is -2. -1 times 1 is -1. Plus 1 is 0. Again, that's our objective, which is what we want. -1 times 3 is -3. Plus 0 is -3. Alright, let's go ahead and rewrite our new matrix. We used equation 3 or row 3, so that one doesn't get affected. We didn't touch 2 at all. This one doesn't get affected. And now we are writing this result, right? This is our new row 1. So we're saying 1, -2, 0, -3. Now what you'll see if you kind of watch this is that since there are zeros right here and right here, and likewise, that leads it to not affecting this entry or this entry. And that's what we want. That's by design. So you want to do this. You want to start working your way up once you have everything simplified to where there are zeros underneath columns, where it's just one entry, okay, and then zeros everywhere else. It doesn't necessarily have to be in triangular form. It can be in another form, but it needs to have, you need to have the form where there's one entry and then zeros down the entry. One entry, right? And zeros down the rest of the column. All right, and now for our final move, I'm going to go ahead and clean this up a little bit now that we are on board. For our final move, we want to get rid of that -2 up in our first row, second entry. So what we're going to do is we're going to say 2 times row 1, and I'll go ahead and use this arrow here again, and remember that means into, just to kind of let you get familiar with that. Oh, and excuse me, this is actually row 2, isn't it? 2 times row 2 plus row 1. All right, into or plus. All right, so then let's do this. So 2, boom, boom. Just going to go ahead and fill that out and make this a little more efficient. 2 times row 2, well, row 2 is 1, 0, 1, 16, and then we're adding it to row 1, so we have 1, -2, 0, -3. Well, what do we get here? We get 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus -2 is 0. 2 times 0 is 0 plus 0 is, guess again, 0. 2 times 16 is 32 plus -3 is 29. And now this is our new row 1. So let's go ahead and rewrite that. Row 3 didn't get touched, so it doesn't get changed. We were using row 2, so that doesn't get changed. And we were adding row 1, so that does get changed. So now we have 0. We had 1, 0, 0, 29. All right. So now look. Now we have an entry here, here, and here. And then everything else is zeros. All right? So let's go ahead and represent this using our equation, and you'll see why this is important. So now we have x1, we have x2, and we have x3. And all of these have a 1 on them, which is nice. And let's see what we get here. And what do we get? And I'm going to go ahead and go back to the green for this. Don't worry. All right. I'm going to go back to the green like in the last video when we started. And now this is what we see our linear system getting reduced to. But what does that mean? What does this right here mean? What this means is that the point 29, 16, 3 solves our linear system, is a solution for our linear system. If we plug in this point right here, all right, into all of our equations separately, they will be evaluated to true in the equations from the last video. All right, it simultaneously solves each one of our linear equations. Now, in a couple videos ago, we kind of visualized what that looks like in 2D, where it was just two lines that intersect at one point. Well, now it's very similar, except now we have planes that are intersecting. Okay, so now it's just an idea of a three-dimensional representation, but this is what that means. So now we have come up with one solution to our linear system. All right. And it's really important, and what we'll see a lot in linear algebra, as I have mentioned before, it's very repetitive, it builds on itself very nicely, is that this is actually what is called a unique solution right here, is this right here. unique. There is exactly one intersection point of our 3 original equations, and that is it right there. And then we'll kind of dive into the existence and uniqueness questions much more in almost every kind of concept and aspect of linear algebra that we touch from here on out.